All right, you guys ready? Good morning, welcome to our design review. We are the Purdue Ecuador EPICS team for the spring 2015 semester, and we're excited to be able to tell you a little bit about our project. We'll go ahead and, it doesn't work anymore. We'll go ahead and introduce ourselves as a team. So I'm Sam Albert, I'm the project manager for this semester.
I'm Alex Marshall, I'm the partner liaison for this semester.
I'm Nick Chittick, I'm the design lead for the CEB team.
I'm Frank, I'm on the CEB team and I'm a financial officer.
I'm Nick Mack, I'm on the CEB team and I'm also on the grant team.
I'm Brock Smith, I'm on the grant team and I'm helping with the website.
Hi, I'm Paige Sturdy, I'm a partner liaison and a cultural liaison for the materials analysis team.
Hi, I'm Sadie Argus, I'm the design lead for the materials analysis team.
Hi, I'm Dana Hayskamp, I'm financial officer and cultural liaison for the CEB team.
All right, yeah, go ahead. All right, so I'll give a brief overview of our agenda for the day. We'll start out with a project overview, talking a little bit about what our project is, what we're doing. As part of that, we will talk about our project partner and our relationship with them, some of the culture that comes with that, and additionally, the background of the team before this semester began. Then we'll go into the design process, talk about where we are in that. From there, we'll talk about specification development. Then we'll move into conceptual design, and we'll hear from both of our design teams. We'll also hear about our budget and our process of seeking out grants for the semester. And then we'll do a quick recap of the progress that we've made and some of our long and short-term goals. Move on. All right, so an overview of what our team is doing. Our overall project is to build a community center in Lubici, Ecuador. For this, we are considering which material would be best to use for the building. So we are creating a decision matrix that is analyzing, I think, 8 different types of materials and grading them on different attributes, different pros and cons. One of those, the most unique, is a compressed earth brick, or CEB. This is a somewhat, well, it's a tested material, but it hasn't been used as widely as the others, so we're conducting some of our own testing, and that's the job of the CEB team. So that's what they're doing for the semester. They're creating a prototype, and in addition to those, we have some smaller teams and roles, including the archivist, the cultural liaisons, the project partner liaisons, financial officers, and people seeking out grants, as well as those working on the website. So now that you've heard some about how our team is split up, we'll go ahead and hear about who our project partner is from Paige.
Our project partner is called FEVI. I won't give you the Spanish the Spanish of it, but the translation for FEVI is the Foundation for Education and International Volunteering. They were recognized in 2005 by the Ecuadorian government as an NGO. This NGO is run by Maria Barragan, who's the person we're in contact with all the time. Pretty much the mission of FEVI is to support education in low-income areas and to promote local and volunteer work. So they do a lot of projects involving like building schools and teaching women how to like sew or make jewelry or things like that. They also have done things with gardens, like making an organic garden in the community we're actually working in. Some other things for volunteering is that they take the students that come from America and give them a place to volunteer at during their time in Ecuador. So a little bit about the background of our project. This was formerly a global design team through the Global Engineering Program. So in fall of 2012, a grad student from Civil came to the Global Engineering Program, and he really talked about how this community needed resources and needed help building this community center, and asked them to take it on for a global design team. Brandon Folk, our advisor, got word of this, and he actually started traveling there in the winter break during the fall of 2012 semester. And during that time, he kind of started off building a relationship with the people of Lubici. As you can see here, he met some of the kids that we're actually going to be designing this building for, which is really cool. And then the following spring, we actually had a team together, and we started building up CAD drawings and Revit drawings and things of that nature for the community center, and just talking about what was actually needed and required by the community. And then that spring we realized that we just didn't want to go in there and build this community center and be done, but we actually wanted to show them we were in this for the long haul, because we realized it was going to take longer than one semester to design this community center. So we took a team of 5 people to Lynn, BC in the spring of 2013 during spring break. And we built a handicap ramp at the existing school, as you can see in this picture, it's right there. And yeah, because they needed it to be handicap accessible for a student that was actually attending at the time. And then the next fall, we continued on with our designs, and then we actually went there and built some bleachers for the parents to sit on whenever they had programs such as plays, and they had soccer games or volleyball games or something like that. And then Claire's going to tell you a little bit about our documentation and our AutoCAD and Revit drawings in preparation for all this.
All right, Claire would normally talk about this right now, and then we're going to pass it off to Dana for cultural readiness. So as Paige was saying, we really wanted to get involved with the community, and more so than just going there and building a project. So in order to prepare for that, we really wanted to create a team atmosphere where we understood not only the community, but also some wordings of how we state our project. In order to do so, we created some Quizlets, or Spanish lessons, so that we can communicate better with the people of Lynn, BC. We'll also be sharing some videos about Quito and Lynn, BC. Those are in the works currently. We also shared a document about helping versus serving, which really talks about the language that you are utilizing with talking about a project, where you're going not to help where the people are lesser, but they can actually help to help you determine what you need for the project, because they are equals to you. We also plan on having some guest professor lessons to utilize more. Yeah, I'll fix that. Now we're going to pass it off back to Sam to talk about the design process.
Okay, so this is a picture of the design process that is specifically for EPICS. These are the 2 phases that we are in right now. It's a little bit unusual to be in 2 at once, but as a team we decided that's what fits our needs best. So starting with the specification development phase, coming out of the global design team, there wasn't great documentation of their specifications. So even though some design work has already been done, we don't have all the documentation required by EPICS for those specifications. So we're working on that right now to make some of our own. Another issue is that while the project was kind of sitting in between the global engineering program and now, some things changed, the school has grown, so we're making sure everything's up to date, and then we have sufficient specifications. We're hoping to be done with this by the end of the semester, and just making sure that our specifications are specific enough. Moving on to conceptual design phase, as well as seeing that the specifications needed to work, it was also clear when the project came into EPICS that there were some things that were already in place to be done. So determining the material for the building, and more specifically looking into the compressed earth bricks and researching those, it was clear to us that that already needed work. So we are in the conceptual design phase in that sense, because we are prototyping and we're considering different design solutions there. So we're sort of in both, but by the end of the semester we plan on being done with specification development and completely in the conceptual design phase. So moving on from that to talking about the design specifications, these are most of the ones that we have right now. As you can see, there's a pretty good list of specifications here. We have a good general idea of what we want the community center to be like, such as the different rooms that we want in it and things like that. But you might also notice there's not a lot of numbers in these specifications. So what we're working on now is taking this more general idea of what the community center should be, and working with within our team, with Brandon, our faculty advisor, and with other faculty at Purdue, to make sure that we can put numbers on all of these ensure that all of our specifications are both quantifiable and measurable. Again, we plan to have this done by the end of the semester. That's really all we have for the specification development phase, so we'll move on into the conceptual design phase, and Sadie is going to talk about the material analysis team, what they've been doing.
Before we knew what direction our Ecuador team was headed, we first decided we wanted to do some research on materials that could possibly be used to make our community center. As we split up into two groups, the material analysis team decided to do more research, more in-depth research on the materials that we had previously chosen as a group. Wait, should I talk about the Gantt chart at all? Should I remove that?
It's in the slide after this, right? Did you move it?
It's in 2 slides forward.
Yeah, so you can talk about it then.
Okay. So as a team, we determined a list of possible materials. With those materials, we created a design matrix, and we are using certain parameters as research guidelines when going more in depth as a team. We split the different materials among the group to be researched, 2 materials per person on the team, so that each material gets the research it deserves. Next. Oh, you're already there. This is our design matrix. This is a list of the materials that we have chosen as a team. This is how we are going to measure, or how we are going to research each material, and this is how we are going to measure each material on those metrics. And this is our Gantt chart. As of now, we are in week 7. We are working on our research as a team. We have already determined our metrics, already made our matrix template, and now I'm going to turn it over to Nathan. Nick? No. What about the?
Yeah, so
that was
what you
his
just
slide.
said
That
would
was
have been,
him.
but it's okay.
Okay.
I thought you were just filling in.
I was.
So you turn it over to me.
So I'm Nick Chittick. I'm the design lead for the CEB team, and the other members of our team are Nick, Frank, Alex, and Dana. And what we've been working to do is design and build a machine that will be able to have in Ecuador, in Lubisi, that will make usable bricks that they can use to actually construct the community center that we're going to be building there. What we looked at originally was something that we had found online that was existing technology that Frank's going to go a little more in depth on, but we eventually ruled that out and came up with our own model for what's called a CEB press, which is compressed earth brick. And what it does is, as the name suggests, it literally takes earth, dirt, and compresses it into a brick, and that's an example of a brick that was made this way. And a couple quick advantages of it are that it's really cheap. It doesn't require really any materials because you use the dirt that you already dug up during excavation, and it's also sustainable. It doesn't have a big carbon footprint. It's not bad for the environment because it's using the environment. And through our research on the actual bricks, we found that it'll take approximately 3,000 psi to compress this dirt. And so really that's the number that our model based off of. That's what we used. So,
What was that other bullet point that you wanted? It didn't say.
just type working prototype. So what we're wanting to do is make a prototype of this CEB press, the compressed earth brick press here, and so that way we know how to do it and we can make an identical model in Ecuador, so we'll already be experienced on building it so that once we get there it should take very little time and minimize the cost. So we'll end up having 2 models of this. Good. Excuse me. So this is a very rough sketch, idea of what we're going to be using for both our prototype model in the States and in Ecuador. And what we're doing is really a spin-off of existing technology because we're using what's known as a hydraulic log splitter, and I'll go ahead and explain how that works in its intended purpose. So there's your engine, and then you've got your hydraulic arm and your manual control. And what happens is you would put a log right here, and with the manual control you push down, and there's an axe head right here. It's kind of covered up by the blue box. But what would happen is when you have the crank go, the axe head would push downwards on the log and split it into smaller logs that could be used for for a fire to heat a home. So what we did is we are adapting a log splitter by attaching a flat, just a very simple press, and then putting a molding below that will actually hold the dirt that's going to get compressed. So I'll go ahead and give a little demonstration of what's going to happen there. So what we would do, this is our mold prototype, is what we do is we would fill it with dirt and then pull the hand crank down, and this head would come down and compress the dirt, and then you just take the mold out. It's actually got a hole underneath that a hammer would be able to fit through. So you hit that with a hammer and a brick would slide out of the mold, which could then be used after being cured. It could then be used for the construction of the building. So our goal is to make maybe a few of these so that one person could be filling the mold while another person is pressing, while a third person is, say, taking the brick out of the mold. So we really get an assembly line going. So we're really working on that design right now of making a mold that works and is obviously made out of metal and not wood, so that it would actually stand the 45 tons of force that would be used to press down on the brick. So now Frank is going to go ahead and talk about some of the pros and cons of this design, as well as a little bit of an overview of what we were originally looking at doing and why we ended up going with this model.
Alright, so when we were deciding to actually go with the log splitter idea, we were strongly considering another idea, which is a compressed earth brick machine by a community called Open Source Ecology. And this machine right here was our first option. This actually cost around $4,500 to make, and it also needs electricity in order to run. It has electronic parts, and it's quite complex to make. When we were deciding whether to go with this or when we have the other option, we decided that the log splitter idea would be better for a number of reasons. Number one, it's about $2,000 cheaper than this brick press and other options we found online. The log splitter is also mostly manufactured. This CV machine by Open Source Ecology we'd be making ourselves, and that opens a lot more room for error and just general safety hazards overall. It would also be much harder to construct actually down in Ecuador. And the log splitter, as it is mostly manufactured, there's a lot less that can go wrong, and we're just simply modifying it. And log splitter is actually the basic idea of how this actually compresses the bricks. So there's just a hydraulic press in there that would compress the bricks the same way the log splitter is doing it. The log splitter also operates on gasoline, like the CEV press, so that way you can run it pretty much anywhere else. You don't have to have it, tethered to electric wire the entire time. It's also capable of being converted back into a log splitter. So when we decide whether we want to leave in Ecuador or take it with us, if an option comes up where we just have to leave it there and we don't want it to be a CEV machine, we can convert it back into a log splitter and find someone that would get the best use out of that. It's also much more mobile. As you can see, this thing weighs quite a lot and requires several people to assemble. It would not be the best idea. And log splitter, we can pretty much put it on a truck and take with us wherever we need to go. Some of you are probably thinking, oh, compressed earth brick, that's not that safe. Well, compressed earth bricks are actually stronger than adobe bricks. Now, adobe bricks, those of you that do not know, are widely used in New Mexico to construct some houses. In New Mexico's state requirements require that the bricks have a compressive strength of 300 psi. Earth bricks typically test out about 750 psi. So it's much stronger and much safer than using adobe bricks, if done correctly. Cons of our log splitter are we need a model that has 40 plus tons of force, and those models are somewhat far and few in between compared to the lesser strength models. and we're trying to figure out the exact model that is available here and in Ecuador. The entire process is also manual. So for this machine, you load dirt in the top and it would just like kind of spit them out on a conveyor belt. But obviously we don't have that with log splitter machines, so that's why we're making 4 molds. And you put in the dirt by hand, you load it under the machine by hand, you take it out by hand, you take out the brick by hand. So it's a significantly slower process, but it's also, there's much less room for error. Like I said, if this were to break, then you wouldn't really even be able to make earth bricks at that point. Yes, you can go to the next one. Okay, our current plan is to fabricate 4 stainless steel molds that would generally look like this. And we have a base attachment system to help hold each mold in place. Think of a Lego, and basically we would stack this on top of the base mold, and that would keep it from turning or moving during the compression process, which we would not want. And the molds would create standard bricks, and the bottom of the mold would be inch-thick steel, while the walls would be half inches thick. The mold height is significantly higher than standard brick, as you can see. That is so you can load the dirt in that needs to be compressed. And we're going to attempt to create these in the artisan fabrication labs here, which would allow us to create them for a fraction of the price. Oh, I will now pass over to Nick, who will talk about Alex, who will talk about the future of this.
All right, for this semester, we still have some things to do. For example, we need to actually build the prototype, the CB prototype that you were talking about. First, we need to get a log splitter that will be readily available in Ecuador when we decide to go there, so that we're not using a different one that we would be testing here. Also, we need to obtain the material that, like, the soil that we would be testing in the future, in the summer, that Nick's going to get into more detail on. We need to obtain this material so that we can make sure that it, again, is the same material that we're testing that we're going to be using, so that there are no differences and no unforeseen problems. Also, we're going to develop a test for this summer so that we can upload our findings into the decision matrix that the materials analysis team has already made, so that we can determine what is the best material to make. When testing the soil, we will be testing different types of soil, different mixtures, more cement, less cement, to find out which is the most stable and which is the most capable of dealing with the elements that they will be exposed to in Ecuador. And now Nick will be talking about our future plans for the summer.
So after the summer, or in the summer, basically all we're going to be doing is putting into motion all the plans that we're doing for this semester. So we'll have what type of tests we want to run, and we'll have obtained a pile of dirt, basically the same materials that we'll have available in Lumbisi, and then we will just make bricks for the first part of the summer, and then we'll submit those bricks to a variety of tests. That way we can make sure that the bricks that we'd be able to create in Lumbisi would be able to hold up to like the correct standards and be a viable support method or building material. After we run through all these tests, hopefully we'll be able to look at the data and analyze it a bit, and to determine whether there's anything that came up that we learned from that we didn't realize currently. And then we can either make a modification and like rerun some of the tests, or if there's no significant results that we know, then we'll be able to go directly plug it into the decision matrix, and we'll know what material we want to build the community center out of. So now,
the Gantt chart. Sorry.
okay. Oh no, you're right. I forgot about that. So looking here, we're in week 7, and we already have a rough idea of what our materials are needed, and we've looked into where to get them at the AFL lab. And now progressing onwards, we're going to research the different soil mixtures, and we'll build our actual prototypes to use during the summer. And then towards the end, we'll determine what type of tests we would like to do. And into the summer, there we are actually doing the testing for the prototype. And now it should be Dana. And and Brock will talk about our budget and our grant sources.
All right, so we estimated the cost of the current CEB prototype, and basically since we're going to be creating it here and then again over in Lumbisi, we need 2 log splitters, which are estimated to be approximately $1,749 each. And similarly, we need 2 flathead parts in order to do the compressing. And we are going to create 4 molds. Both of those 2 things will be created in the AFL using hopefully the material that they have available or low-cost material from outside sources. And we also will be needing an extra axe head and gas to run the machine. The actual building itself that will be created has not been budgeted yet because we are still working on the specification phases for what details need to be included in the building.
For the grant team, we started out the semester not really knowing what we needed and what we wanted to do, so we just made sure to cover our bases and applied for a grant, which we got for $1,500. We also have the $200 from EPICS. And now going forward for the rest of the semester, we're looking at other options for donations from companies, and we're looking at that to make sure that we're well prepared for future semesters for the fall and the summer for actually building the cost of building the building.
And then you'll pass it on to me.
Okay. I'm going to pass it back to Sam.
All right, so to wrap up and kind of sum what's been said, we've got short-term, mid-length term, long-term, and continuing goals that we're thinking about right now. So some of the short-term goals that we'd like to, or that we plan to complete by the end of the semester are to finish the CEB prototype, to complete the material analysis decision matrix, and to make sure we have all of the specifications nailed down. Moving forwards from that, we want to make sure we're continuing to learn from the global design team members and get as much information from them as we can, as well as go through some of the design work from that phase of the project and determine what's usable and what's not, and we'll use our specifications to do that. Our long-term goals, actually designing the community center, is of course a long-term goal. From there, we will determine a work plan, a schedule of how we will build the community center there, make sure we have all of the resources in place, such as the labor for doing so, and then actually build the center. And even further than that, making sure that we follow up on that, continue our relationship with them. Speaking of that, some of our ongoing goals are to maintain the relationships we already have in Lumbisi, make sure we're always making even more, getting into the heart of the community there, and also always seeking out funding, making sure that our project doesn't lack in funds. So that wraps up our presentation for today. If any of you have questions, feel free to give us your comments or advice as well, and you can get into this time. And also, if you think of a question later, but not right now, feel free to send them to me. My email's on the screen, so we're happy to take them later as well. So does anyone have any questions? That's it. Yeah.